Hey everybody. So I wanted to do one more problem, and I wanted to make sure I did one that asked us to do the confidence interval. I still have confidence interval stuff showing there. Okay, so clearly I ran through this problem already once because I actually find these pretty tricky. Um, so let's run through and take a look at it here. So, study of red-green color blindness, 750 men and 2,700 women are randomly selected and tested. Among the men, 65 had red-green color blindness, and among the women, 8 have red-green color blindness. So you guys should all be jumping up and down and going, there's a difference! Let's go ahead and see what those proportions are. Remember, proportions are just the division here, normally expressed as a percentage. So about 8% of the men, well, let's do this the easy way. Let's drag it across. And about 0.2% of the women. Overall, we see that there is, and I'm cheating, I did one sum, I did one proportion, and I just keep copying the formulas. About 2% of the population actually have this red-green color blindness. It's a really terrible one. You end up getting in accidents. So I have the men, I have the women, and then I have everybody together, right? The pooled proportion. So to do the statistic and the p-value, we have to use the pooled proportion. So first I'm going to compute the SE. Remember, the SE was the square root of the pooled proportion, and then 1 minus the pooled proportion divided by the N1. Plus the pooled proportion times 1 minus the pooled proportion. Oops. Sorry guys, there's a typo here. That's a plus right there. And I want to divide by the N2. Just writing my equation out that I'm going to use here. So it's SQRT. I'm going to reference this value a bunch of times. Divide by the N1, that's the 750, the number of men, plus, again, that pooled proportion. I need a times there. Nope, I don't want a P there, though, do I? Oh, watching people program is very annoying. Okay, there we go. So that's my standard error, I think. No issues with my formula, right? I think I've done it correctly. All right, that's my standard error. Let's see. Rather than just jump to the Z, let's do the P1 minus P2. Since I'm going to have to do that in a second, right? So I'm going to do equals, do that one minus that one. So that's the difference between those two proportions. Pretty big. So then my Z is, of course, let's write it out, P1 minus P2, all divided by the SE. And I do need some parentheses here. So for me here, it's actually just this cell divided by that cell. Whoa, that is a huge z-score. A huge z-score. Remember Z being about 3 is pretty big. This one's huge, enormous. 14 is giant. Let's go ahead and convert that to a p-value while we're here. So the p is norm dot, I'm going to use the s dot dist. I give it the z value and I tell it yes, I want that to be cumulative. Gives me a p-value of 1. Remember though, I want the tail, so I should do equals 1 minus that value. And I get a p-value of 0. Now, normally we don't report p-values of 0. We say something like less than 0.001. But here I think WeBWorK is going to take 0. Actually, I know WeBWorK is going to take 0. So is there sufficient evidence to support the claim that men have a higher red-green color blindness than women at the 0.5 significance level. You better say yes to this. P-value is 0 here. It's less than the significance level. So let's go ahead and hit submit. And I got that part correct. Great. Those are always the easiest questions here. I'll come back and sometimes notice students just have a third of the questions because they got the multiple choice and just moved on. Let's do the confidence interval though. So I want to construct a confidence interval for the difference between the color blindness of men and women. All right, so this is the trickiest part here. So before, when we did the difference in, when we did the color blindness, when we did confidence intervals, we would just do our SE times our Z star times our Z, and let me write it out, times our Z star. Right? And then we would do that like plus or minus our test statistic. Actually, we'd do it the other way, wouldn't we? We would do our stat. I'm going to get it eventually, guys. Plus or minus our Z, our SE times our Z star. Now here's the issue. Is that we have accepted that there's a difference between the men and the women. So this pooled SE no longer makes sense to use. The pooled SE doesn't make sense to use. We know there is a difference between men and women, and we're trying to express where our confidence level is of that difference. So in order to do that, I'm actually going to have to recompute the SE. So I need a different SE here. This SE is going to be the square root of exactly like I did above, except now I'm going to use P1 and 1 minus P1 and divide by N1. Plus, I'm going to do P2. I'm not going to use that pooled. I'm not going to use the pooled proportion because I know there is a difference. It looks like the almost the same formula if I drop the 1s and the 2s off the P. But I don't want to use the pooled proportion because I know that the things are different. So let's do this real fast then. Square root of this one times 1 minus that one divided by that one plus, sorry about the phone, guys, this one times 1 minus this one, all divided by that guy. So it does come out to be quite a different standard error if you look at it. Quite a different standard error. So that becomes important. This is our standard error when we already know that they are different. Okay. I need the Z star too, don't I? So Z star, I want a 95% confidence interval here. So if I want a 95% confidence interval, I'm going to do norm.s.inverse. And the probability that I want for this one is 0.975. So because I wanted a 95% confidence interval, I want 2.5% on either side. So I'm going to have just a tail of 2.5%. So I normally use 2 for 95% confidence intervals, but for WeBWorK, I should probably be a little more accurate. So I think I have all the pieces. By the way, guys, I wrote stat here. That's the P1 minus the P2. I'd already computed that. So I think I'm ready for my confidence interval. So let's write my CI, and we'll get my lower and my upper, right? So my lower bound is going to be the stat minus the SE times the Z star. And my upper bound will be the statistic plus the SE times my Z star. And so I have these two, and I'm just copying and pasting here. And then I need to evaluate this part. We can be 95% confident that the difference between the rates of colorblindness for men and women lies in this interval. There's a 95% chance that the difference between the rates of men and women lie in this interval. We can be 95% confident the difference in rates for men lie in this interval. So the difference here is sample, chance, and then it doesn't have that here. So when we're doing a thing here, I want to be really clear. We did a sample, right? We had a sample, and the sample that we had, that difference lies right in the middle of this. So it can't be A. And then this thing about the 95% chance, that we're not going to talk about chance here. We really want to talk about C here. That we're 95% confident. We're going to talk about confidence here with our confidence intervals. So let's see if we got all those right. We did. Okay. So we're 95% confident that the difference between the rates lie in this interval. We don't want to use that chance word. All right, ladies and gentlemen. So that is how you do this one with how you do comparing to with a confidence interval. And again, I only do this, I only do the unpooling when I go for the confidence interval because I've really already accepted that there is a difference. Okay, guys, keep working hard.